is 2025 AMC 10B, question number 25, the last question. Square ABCD has a side length is 4, and the point P and Q lie on the two sides AD and DC. AP is 8/5, DQ 10/3. A path begins along the segment from P to Q and continue by reflecting against the side of ABCD, okay, with the congruent incoming and outgoing angles. You can see here, they just reflected on the point of Q. If the path hit the vertex of the square somewhere, and you just stop there. Otherwise, it's going to be continue forever. At which vertex does the path terminate? Are you going to play with this one manually, finding the path? You get lost. For example, I'm going to go from here, reflected, going, and then going here, and then reflected again, get the same angle, reflective from this side. I'm going to continue. And then you definitely get lost because that are not going to be easy to find out the next stopping point. And also it's really hard to find where we can find the terminating point for the vertex. We cannot do manual manipulation from here. So the way for such a question is strategy going to make a copy for the square. Because instead of turning from here, get a reflection, I let these lines continue just like, like a beam. You just let this continue traveling instead of just turning from any point. So if I make a copy of this square, you can see this line segment supposed to be here, but are going to be replaced by this. And also C to B, I'm going to do B reflected here, and then still continue along CB. And then you're going to get the second stopping point. Without turning, keep the angle and keeps the length. Keep the angle because it's reflected. Definitely that will be vertical angle and that will be equal. And also we keep the same length. These two triangles are congruent. So these two segments will remain the same length. And I'll continue make a copy. Over here, we are not going to turning. Over here, we are not going to be turning at this point. Instead of going to keep traveling along the same path, we get a third segment. So we make the lines straight without turning and also keep the angle. Because you can see this will be continue, keep the same angle right here. Okay, because this is the congruent, getting the same. So, and also we keep the same length for the path, the segment 3. And then we're going to continue make a copy. Over here, I need to make a copy from the right side. We get the segment 4. Continuously, we're going to doing this one, get a 5 here. And then we want to reach to a corner somewhere. And then if we make it, that's going to be very straight line from the point of here, P, all the way to the ending point, whatever the vertex yet. This, we don't get the answer yet, but we're going to find out eventually the answer should be B. So I need to find out how many copies of the squares vertically above this bottom square. How many squares horizontally should be a copy, including the original one, because this is the starting from the very beginning part. So let's say this n squares at the horizontally, m square vertically beyond the first square. And then in that case, we can find out the two similar triangle, P, P prime B, and also this PQD. This should be similar. So you see n copies, vertical is m copies. We get the blue triangle similar to this little bit of purple triangle. And then we just use we try to find some of the legs, DP, will be 4 minus 8 over 5. This is AP equal to 8 over 5. So this is A 12 over 5. So DQ is 10 over 3 is given. So therefore, I can find the leg ratio DP to DQ is going to be 18 over 25. 12 over 5 times the reciprocal of 10 over 3. So you get an 18 over 25. So leg ratio is 18 over 25. The two triangles similar, we're going to do the short leg BP prime right here. And the long leg is just the horizontal line here. So PP prime. So that's equal to the short leg to long leg. The ratio should be 18 over 25. So this is BP prime. You can see this will be DP. The length is 12 over 5 plus m squared. So each of the side length is 4m. So you add 4m. That will be the length of a BP prime. Horizontally, each one is a 4. So you get an n of them. So 4 times n will be the length of this horizontal leg for this large triangle. The ratio should be 18 over 25. Simplify, that cancel the 4 for the left-hand side, for the top and bottom. You get this. I'm going to multiply by 5 on the top and bottom. You simplify this complex expression, 3 plus 5m over 5m. So you get 18 over 25. So I'm going to cancel the 5 and the 25. So the left-hand side, the bottom is n, the right side is 5. So we get a simple ratio equation. After that, we just solve for the n and m as an integer value. Just do cross multiplication. So 15 plus 25m equal to 18n. Least the value of mn will be really simple. M will be equal to 3. You get a 90, this one, n equal to 5. So that means vertical need 3 copies and a horizontal total will be 5 copies, including the original one. Now is the time we're going to find out the vertex, the one we're looking for. By looking the reflection, this is the A reflected across the BC become A here. Another one reflected, and then this will be AB, this will be A reflected, and this will be B right here. Reflected across this corner, this line, you're gonna get a B here, and then you're gonna reflect it across this line, you get a B on the very top corner. That's the answer then. So we just figure out the solution by making the copy and using the reflection. We find out the path, which is the smart way to find out the total path until it reaches the destination. That's it. Thank you for watching.